Hey all, welcome to ShareTrek. This is Raj here, friends. As you can see, I'm experimenting with my studio again. I want to make things look better, but right now the set I have seems like I would be telling a bedtime story to somebody in this set. The colors are all looking like very dreamy. So just please bear with me until I find the right mix. We need to keep on changing, improving. That's my philosophy. So I don't like to stay with the same background and everything. So I'll be working on some changes. I just request you to indulge me. That said, hey all, welcome to ShareTrek. This is Raj here. There seems to be a bunch of trends in genomics where startups are gathering, and there are some big tech names also getting into the field, names like Microsoft, Amazon, Nvidia, etc. The great convergence that Kathy Woods was talking about is happening, and it's happening at the leading edge. One of those is genomic data analysis. When I say one of those, I mean one of those 8 trends that have been observed is genomic data analysis. Another one that we are already familiar with is the NSG, next generation sequencing. So we are already familiar with that because we are covering Illumina, we are covering PACB, Oxford Nanopore, those kind of companies, Bionanogenomics. So that's taken care of. So today I want to talk to you about genomic data analysis or genome data analysis. But before I proceed for daily content on genomic investments, I would recommend that you please do not forget to subscribe and press notify if you have not already done so. Help us grow this channel. That said, let's get started. Welcome back, friends. Now let's talk about genome data analysis. As genomic sequencing improves, there's an accumulation of genomic data in various places. This provides the exciting possibility of first organizing them in a logical manner with requisite identifiers so that they can be grouped and cataloged. This in turn lends itself to the possibility of pattern matching and identifying anomalies and then correlating it to disease or syndromes. The advent of sub-$100 genome sequencing means we now have more data available and we are generating more data. And this is where genomic data analysis comes into picture as a new trend, which will enable to get the full potential out of the vast amount of genomic data that we have accumulated in different places, in different research institutions, in different hospitals, in different corners of the world. It's all sitting in smaller pockets here and there, and people are having partial view. But if there was a way of anonymizing data, putting them all together, and then on top of it providing tools to do manual analysis and then providing machine learning tools, providing AI tools to do some kind of computational analysis. All those prospects are very, very ripe for the picking at this point of time, and many genomic companies are going into that area. Small data sets are handled in a smaller context. However, huge genomic data is available from different sources and consolidated. Computer science and AI offer a whole host of functionalities on top. These could be, as I mentioned, anonymization, machine learning, pattern scanning, etc. At the same time, there are data troves which are huge because they are all consolidated, and genomic data by nature is huge. And in fact, just a quick segue from here, there is an old video of ours, of mine in this channel, where I'm talking about data storage methodologies. And one of the main concerns for data scientists is that we are running out of space to save data. Even though we are miniaturized, I mean, in a small chip, we can have 1 GB of data, 1 TB of data, but still the rate at which the data is coming and the rate at which we are computing and creating information and storing them all in a digital manner, including images, music, and everything, means that we need much better data storage. And if we were to do some space travel, the kind of computing and data involved in that would be so huge that it will cost a lot of freight to pick them up and send them to space. Therefore, people have been investigating DNA data storage. So that's the kind of situation that we are in with regard to data storage. So coming back from that segue into our topic, while scientists would like to focus on their core interest, that is managing the database security and algorithms would not be feasible, as these data sets need sophisticated equipment to handle the capacity and also have the capacity to hold the data, the security, the speed of access, etc. Generally, a scientist would not like to involve himself or herself in all those kind of activities. They are focused on genomic research, and they need the tools. They know what the data looks like. They know what to look for. They need the tools that will enable them to look for that very quickly. They already know what they're looking for, but they need to have pattern matching tools that can match the patterns across a huge database of genomic data. Those are the kind of things that they are looking for. So this is where there is a big opportunity, and many startups are targeting this area. While startups are trying to get into this area, we already have big tech like Amazon who are offering very powerful platforms that includes genomic data sharing between different entities, so that personalized medicine, developing treatments for genetic disease, and finding genetic markers become much easy. And genomic data analysis also looks not only at DNA, but also RNA and proteins. The end objective of all genomic data analysis is to either diagnose genetic disease or develop drugs. Those are the two main major objectives. Machine learning, statistical software, sequencing technology, and visualization tools are used to perform genomic data analysis. And presently, the global genomic data analysis and interpretation market size is estimated to be around $1 billion at present, and it's expected to grow at a compounded annual growth rate of around 10.25% to reach $2.15 billion by the year 2030. Illumina offers cloud-based genomic data storage facilities to its clients already. Microsoft has a host of cloud-based data analysis offerings, such as Cromwell, developed by Broad Institute. And they have actually, Microsoft has 4 distinct offerings in this area. You can always search for Microsoft Genomics and have a look at what they are doing out there. I'm really glad I have Microsoft in my portfolio. I have Microsoft, I have Google. The only one I don't have is NVIDIA, and as soon as I get an opportunity, I'm grabbing it, because we have NVIDIA with their Clara Parabricks offering, which again is a powerful tool. Of course, they have already done Cambridge, in which they are working in UK on genomic research. And so it's a huge field. It's one that we should not lose sight of. In subsequent videos, I'm going to talk about the other 6 trends. We already know next generation sequencing. Today we spoke at a high level about genomic data analysis. So that leaves another 6 areas that I want to talk to you about. I'll bring them out in subsequent videos, and we'll cover them in this channel. And if you're interested in this kind of content, please do not hesitate to press subscribe and notify, so that you do not miss any video from here. And if you like this video, please do not hesitate to press the like button, because that helps the YouTube algorithm to send this off to other people like you who must be looking for content like this. And also please consider the super thanks feature to support the channel, and that will give me funds to do all the experiments that I'm doing, buy new lights and camera and all those fancy things. And also maybe subscribe to a few journals here and there to get more information. So that's all for today, my friends, and I'd like to catch up with you again tomorrow. Bye for now.